Good evening, team. I wish to welcome everyone to the fourth lecture under the SmartNet Edu Center. We are continuing over the course that we had started some few days ago, which is the Computer Expert course. The breakdown of the Computer Expert course, we have already covered the first three lectures. First lecture exposed us to computers. We defined what a computer is. We defined it by the four major functions that a computer carry out on its own, so as to give us the feedback. We later on went into the computer parts, that is the hardware segment, understanding how they are interconnected to each other. Further on, we rushed onto the software. Software also went in there underneath, wanting to understand what the operating system or the system softwares are and what the application softwares are, or the user application software. We distinguished between the two softwares, one being the foundation of a building, that is the system software, and the application software, we said there are rooms being built on top of the foundation. And we said foundation software are the key, are the basis for a standing of the application software. So application software cannot run on their own, they need to stand on the system software. And we mentioned that there is a special type of a firmware, which is, so a firmware itself is a software combined with a hardware working together. Now there's a special type of a firmware called a BIOS. Now this BIOS, it's the one when you press on the power on button of a computer. It's the one now that gets the feedback from your switch button to go and wake up the operating system that is stored in your hard drive. Once it wakes it up, it is now this operating system that is waken up that now interacts with the RAM and later on interacts with the hard drive to present this information and be able to post the information or show it on the screen, whatever is contained in the computer. We made one last conclusion in our previous lecture to say your data is stored on the hard drive, meaning your operating system is stored on your hard drive. We also mentioned that all application softwares are stored on the hard drive, but the BIOS is never on your hard drive. It's a reason why when you get your computer hard drive, should there failure comes or what happens to your computer, you're able to withdraw the hard drive, or you've just upgraded, bought a new computer, you can able to withdraw that hard drive, insert it in the new computer, and it works exactly the same. From your password, you'll be able to enter a normal password exactly the way the previous computer used to turn on. That's the way the other one will turn on. If you had put a password, once you just move the hard drive and put in the other one, it will still ask you for the same password. Everything that was on the desktop, everything will be maintained in their respective places. Why? Because the hard drive is the storage. So those books that are stored in there, each one will be on their respective position. What was in videos will be in videos. Everything will be there. In other words, what it means is if you're in the library, with the comparison we gave over studying from the library, if you're in the library, removing your desk, basically, removing your desk is of no use. If they were to remove your desks in the library, they threw them and brought new desks in the library, that will not change anything. The information is still the same. Changing all the shelves, carrying all the shelves that are in that library to a new library that you've bought, a big library that has been bought, constructed in the city, then you remove all those, pushing them there. The library is still the same. The content is the same, because what you're interested in going to the library is the information that is stored in their respective categories. So if that is maintained, then that is the same. Now, that is with the building change. So the building change, we're referring to a computer change. The RAM change, we are referring to the table change, where you're starting from. So basically, the only alteration that will change your computer, if we are to bang the books in the shelves, it will no longer be a hard drive, a library, so to say. So it will cease to exist, because the most important thing about that hard drive or that computer itself is the library itself is the storage. capacity that it has. So we want to build from there, come now to understand to today's critical information. Our lecture today encompasses the networking. We had made this announcement earlier on yesterday. Today's course was to be on the external accessory connections. But external accessory connections basically needed much of the internet. And the second one for printers, we had put something to do with networking. So we have just split them so that we give them enough time to understand each what it means. So on the external accessory connections, we are changed to computer networking. That is what we are starting today. So today we are doing the computer networking. We want you to know, how are you able to connect to the internet? Some of the links that you're learning from the tutorials, they are being sent on YouTube. So you're able to go with that so-called link. It's able to link you to the video that is on YouTube. I want you to understand, what is the meaning of that link we sent you? What is that? And the YouTube, what is that YouTube itself? What is it? How are you able to access information that is there? Is it only that you have to be in Zambia for you to access that information, or you can be outside Zambia and you still access that information? There are a lot of things that we want to understand. What this internet is all about, the networking. By the end of this lecture, what we expect you to come out, or the person who should come out, when you look at a network, you should look at it to be a totally different thing than the way you look at it. Network is not bundles. Network is not bundles, and it will never be bundles. The moment you start looking at network to bundles, then we have lost the key picture of what internet is all about. It's not how many GB are left in, how many what. No. There's something more peculiar about it. To make the issue simple, internet is free everywhere. It should be free. Why do I say so? E.g., do you buy water? This water that runs in homes, basically. Do you buy the water? You don't buy the water. If you pay, you are paying for the service. The water is in the river, be it Kafue River. What these people have done, or the government, by installing that Kafue Swallowed Center or Kafue Mlonga, or whoever is bringing water to your company, Kafue Water, whatever that is bringing water, that company that is doing, they are not making the water, no. Basically, what they are able to do is they are able to pump. So they are adding pumping machinery to pump that water from the river to come to you. But where it is in abundance. So they're able to pump it, they're able to clean it, they're able to keep piping it up until it comes to your home and it is safe. So you are not buying that water like the way you buy Aqua, Savannah, these bottles of bottled water. No, you're not buying this water. This water, you are paying for the service that people are able to channel it into yours, because that longer or Kafue, whatever water company that is doing, it is not making water. It is not making water. It is just facilitating what is there to bring to you. That is basically it. So the same thing with internet. Now, why do we have disconnections of water from home? It's because we're not paying. So once we pay, it's like we have opened the key for that company to delay it to our home. Same thing applies with water. We've talked with internet. The internet, why you get to be disconnected, is because the company that is delaying it to you and making the pumping or amplifying it from the source to keep supplying it over until it reaches your home or your location. You haven't paid, you haven't subscribed for each connection to you. So basically, it's just like a lock. So you buy talk time for 5 kwacha. All you've done is given access to use the window period between 5 minutes. So you can use that window period to do your communication. Once that window period is done, they close it. So you buy 50, it's how much you have opened that window period. There's a lot of interesting features that we can learn from this. Let's go into it because we have a long way to go. And I want you to understand this deep down, go through it. Why you're not clear, we run the videos, go through the notes, understand what we are discussing. Thank you. Let's start. So what are the introduction to the computers? At the moment, we are living in a connected world, of which the information being produced is being exchanged. It's moving from one place to another. What does that mean? It is possible, as almost everyone has everything in the digital world is interconnected through one or the other. Computer network is a group of two or more similar things that are more connected with each other. What do we mean? A friend, networking is basically, you can't be one person and be networked. No, networking is about getting linked to friends, for other people. That's being networked. Nowadays, we talk of jobs and connection. We say, yes, this got network. That's the network that you're building. You're building a group, a number of people to your side. So that is what we call network. Network is just bringing a lot of things together. So we have social networks, that's a friends, Facebook, social networking. You're able to have a friend, the friend has got a friend of a friend is a friend. At the end of the day, there is a network that is being made. We have mobile network. So a lot of phones that have been brought closer together in the mobile devices, so to say. So you can move from one place to another, but you are interlinked to this group, network of computers. So it's computers that have been brought together, a lot of computers that have been connected. Airlines, other things, there are a lot of hospitals because there are a lot of networks, so to say. A lot of things that are brought together. It's a network. Basically, what makes it a network? Because there's an interchange of information that is there. If it's a Facebook, when a friend makes a post, you're able to read it, reply. A friend sends you a song, they tag you in it, they do what? Because of that interchange of information, data has been our resources, so to say. Information or resources is being sent from one individual to the other. That is what we are calling that. So a computer network, it comprises of two or more computers that are connected. That is either by cables or wireless connected. For what purpose? That is to transmit or exchange or share data or resources that we mentioned. Now, you see that this computer is built using hardware. The computer network is built using the hardware because that's what we are going to discuss. So it's built within these chips. These are what comprises the network. The routers, their switches, their access points, their cables. And the software, there is operating system and business application. So basically, this is what comprises the operating system, the network, the computer network. Let's go underneath it. Now, this network, it's categorized. This same connection of computers are connected, all computers are connected. It is categorized according to the space that it has occupied or how many devices have been connected within it. And for such, we have different categories. There is a PAN, which is a personal area network. This is the smallest connection that is there. There is a LAN, that is a local area network. There is a MAN, metropolitan area network. There is a wide area network, which is one. So want to understand how computers are connected because we said the network is just a combination. So two computers, it's a network. I bring this computer, another computer, then I connect them together. It's a network. But now the more we keep adding them and how much space they cover through which information is able to flow, it's what we meant to say it's how the information is kind of flowing, want to say. It's how we are categorizing them. So these are the four categories. Let's go straight to the PAN. So for example, if you have a phone and a PC, so you are connecting your phone to the PC. You are able to get videos from your phone to the computer back to your that. That automatically is a PAN. It's a personal area network because that's how the smallest you can get to be. And you find that these devices can be connected within 10 meters. Mind you, we said it can be via Bluetooth or can be, that's wireless, or can be via cable. So if you have a cable that is 10 meters, a USB cable from your phone to your computer, you're able to send videos, transfer, do all that. That's a network. So that's a personal area network. There is what we call now a LAN. A LAN is a connection for a little bit of a distance. We're talking of an extension to 1 kilometer. The previous one was 10 meters, mostly maximum to 10 meters. But this one, the line we're talking about is up to a kilometer. This is a simple office setup. I'll give you an example. This is an office that is different departments. So this office has this connected, they are connected to the network. The next office is connected to the network. There are 2 or 3 computers that are there. That is what we call a LAN. Within one structure, one building, one hospital, one it has a lot of computers that are there. It can be 50, 40, 40, 60 computers that are connected. And that is what you're able to see from the image that is there. That is what we are calling LAN. It's a local area. The area is one area dealing in one thing that is able to be interconnected, and people are able to share and use printers and everything that is there. Now we have what we call the MAN, the Metropolitan Area Network. Now imagine this is a company, this is a school, this is another. Now the network that brings all this together, it's what we are calling now a metropolitan. E.g., there is a company. For those people that have, there's a hospital nearby, there's a company, there's a school, there's a what. Now, when we connect all those into one, that connection that we have access, that the college can be able to access school from the information from the school, from the hospital, from the other factories or the company, that one is a LAN, is a MAN. Now, that is what we're talking about. It goes up to 30 or 50 kilometers. So it's a wider area covered. Now we have the biggest one, which is a wide area network. The wide area network, actually, it's the biggest. This one can go worlds, continents abroad. You see this type of connection where there are a lot of lands, small lands. You have this computer, this hospital, this what, and you're connecting outside Zambia, you're outside maybe different continents, basically, so to say. So this is the biggest one which we ever had, which is a one. And the one cannot be done by one team. Like you've said, it's international. It's bigger than international, so to say. You can be talking to someone from Asia to hear what the connection that has been done. It's one, so it's bigger than what we think. Now let's look at those devices that are going to be used for this system to get to operate. So in this system, we have what we call the modem. We have the hub, we have a switch, we have a repeater, we have a router, we have a gateway. All these are the devices that we use to connect up this network. Most of you have heard of a modem. Some time back, we used to buy this Huawei modem that would help us to connect to the net. Basically, they will allow us to slot in a SIM card and be able to use the computer to enable a computer to have access to the internet or to be connected. So that is a type of a modem. And this type of a device is just basically trying to change the signal, because what you're getting is the analog type of information that is being sent from your supplier. So this one is just able to translate it from the analog type to the digital type of signal that you can get to use in a home. So that is what we call a modem. You have seen some of them. Then we have what we call the Ethernet card or network interface card, NIC, network interface card, the NIC. This is what we mentioned, found on computers, laptops, desktop, Ethernet cable, Ethernet card. So it's an adapter where you're going to plug in. On desktops, it's an adapter that we get to slot on the extender card. So that card, that Ethernet jack, it's where the computer is connected for wire network, wire connection. So since we said this internet can either be wireless or wired, it's through that jack. That's the cable that we plug in to make sure that that computer is connected. So that is an Ethernet card or Ethernet jack which we connect that. Now they have also given us is a network interface card. So it's a NIC. NIC, it's just the adapter where we connect the internet. RJ45 is just a pin that we use to plug. So there's a cable that is connecting one computer to the other. The plastic ending, that plastic ending is what we are calling the RJ45. So it's a registered jack 45. So it's basically has 8 cables in it. There are 8 that are connected to allow data flow from one end to the other. We have a repeater. Now this repeater is a signal booster. Basically, a repeater is a signal booster, and it can allow data to be, which was being losing the signal, to be amplified. Let me give a good example. The next thing that we are seeing. We have seen this. Airtel has towers, MTN has towers, Zamtel has towers. These network repeaters, they have this type of dish things that are stuck on top. Those are basically repeaters. What are they doing? A signal is sent from the main supplier. Once the internet provider sends this signal can be weakened, because the signal can only maybe take a certain distance in meters, in kilometers, after this signal comes there, it is weakening. We need something that will reboost it, more like a transformer to amplify the signal. So it's just an amplifier of a signal. It will just repeat. So this was weakening. It will amplify it to further keep on. That's what you see these towers. They are repeaters basically. This network, MTN, whatever they put across, they are repeaters. So they are repeating in different directions. No wonder you see them push in different angles, different directions, because network doesn't go. It actually sending it's a directional type of a sending. So it has to be sent in different segments. Then once it is sent, there is another one that is a receiver and a repeater, receiver and a receiver. So it will receive and be able to forward after it amplifies it, the network. Basically, that is what it does. Then there are these small ones that we get to have. Those basically get to do the same thing. We want to talk of a hub. What is a network hub? A network hub is basically a device. So this is the device that we are seeing there with those ports that are a lot of them. Now that hub, it looks like a modem sometimes, looks like a type of a modem. When you push information like a normal jack, you connect that RJ45 into it. The only challenge that this device has is it has to allow multiple ports to be connected. And those ports that are going to be connected are going to allow the information to flow from one end to the other device. The only thing with the hub, or the disadvantage with the hub, is whatever is sent through one port will be released in the other devices that are there. It will be released to the other devices exactly the same information. It will not choose. So if you send a song, you send what, it will, all of it will go to the other devices without control. It doesn't care. So there are 10 different rooms. You send information through one port, the other devices that are connected on the others, they will all receive the same thing that has been sent forward. So that is the hub. From what we can see, there is this computer that is sharing information, just push to one information, the information automatically has been sent. Equal quantity of information has been sent to the other devices. So in other words, there's no secrecy with the hub. It will allow multiple devices to connect together, but one information when sent, it will automatically be sent to the others. Now we come to the switch. The switch is a more latest version, or is an upgraded version of the hub. It will allow you to connect to many devices, to allow many devices to connect together. But this one, the advantage side of it is it will choose one information per device. So, e.g., from the picture that we have seen here, if one computer sends information, they are all connected through this. It's like an adapter for power, where you have only one socket in the house, so you put this adapter that will have about 5 different sockets. So there are 5 different, or the extension cable, so to say. So it will have about 5 different sockets. Then you're able to connect other computers for them to meet up, or the other appliances on that power. The same thing happens to the switches. The hub, what you send, everything will receive. Now the switch is an upgraded version of it. What you send to each one, and you have to select which specific destination do you want that information to flow. So it is a kind of an advanced hub, because it is able to select information that can go into a specific destination and not to the other one. So we can see that data is sent by one node. A node is more like a computer or a device that is connected on the net. We call them nodes. So this node or a computer will send this information through this switch, and that node will receive this information that has been sent. A router, well, a router basically it's more like a combination or upgraded version of a switch. So we will talk of a router. Sometimes these routers, they will have a network card, so to say, like the way the modem will get to work. At the end of the day, it's more like a compressed. How can I say it? It's more like compressed, because what sometimes these routers will get to do, it's just to reroute the information. So it will do something similar to what a switch does, but there is something more peculiar that this router will do. A router, independently on its own, can even allow wireless connection. It can allow, it has the hubs or the ports like the switches have that can do that, but it can also enable Wi-Fi connectivity. So from what you can see, a router can be wired or wireless. A wireless router can provide Wi-Fi access to smartphones and other devices. So once the cable goes in it, it is able to create a password It has a password underneath it. It will broadcast the Wi-Fi name, and people are able to connect to it. That is what makes it special than a switch. A switch will just be like an adapter or extension cable that will just release information according to the information is sent to it. The hub, same as an extension cable, but only be able to release everything that is given. So first one releases everything. The switch be able to release, but only to specific direction. The last one has accessibility or power to enable Wi-Fi connectivity. That is basically what we're talking about for a router. So it will allow more than basic connection of the computers. It will even link them to the network. That is a router. Now we talk of a gateway. So a gateway is basically a route. Why do we need a gateway? Well, a gateway will allow what can pass through. As the term itself suggests, it's a key point through which information can get to flow from one side to the other side. So when you're connected to the internet, information to move from one network to the other network, they have to pass through it. It's more like the only channel that can allow. What is not okay, it will not allow it to go through. That is the difference with the gateway. So it will allow cables to be connected. It will connect to different cables, one from one network, the other one from another network, but will only allow a specific one to go through. Now let's break down, understand what a modem is, a router is, and a gateway. So in the first instance that we are seeing, that is the first instance that we saw, we can see here the modem side. On the modem, there is an internet provider. That is an internet service provider. ISP is an internet service provider. So this is an internet provider, be it Liquid Telecom. So Liquid has sent internet to you. So as Liquid has sent, there is this modem that will allow you to connect. Be it a USB modem, will allow you to connect to the computer, or a special type of a modem that will allow you to connect to the internet. That is one option. The other option, this information has come. Now you can't just connect to one computer. There are many computers that you want to connect to. So you need one extension like a router. You need something that will reroute that information and allow the wireless and wired devices to connect. So you have a router there. From your modem that is bringing the internet, you go into the router. The router will now be able to spread to both wireless and wired devices. The third option is you come to see that the gateway will be like a combination. So information, instead of needing a modem, it will have all those combined in it. It's more like an advanced version of it. But on top of that, it will even control the type of information that can be able to flow through that. So it will have all those combined as one, basically that. So now we're done with for the devices that we're going to use for networking. Now we want to talk of the connectivity of these cables, how the computers are going to be linked together. That is what we call network topologies. It's a geographical, or it's like how we position the computers, how we are going to connect them between the other, one computer to the next, how we're going to do using those devices that we're mentioning. So we have a ring way, it's more like we make a circle, one computer to the other, just like that. We have a mesh. Now this is a complex one. There's a central one in the middle and one computer connected to the other. All computers interconnected and also connected to the middle center device. We have a star. This is where everything is put in from the central device. So there's one central device, each device is tapping information or data from that same central device. There's a tree. Now the tree is a combination, either a ring, mesh, or star. So information, the cables are being delayed. One computer in the third building is coming direct to the other computer. There is another computer is going to the switch before it goes to the router. There is one that is coming direct to the router. The other one is connected. So information is connected anyhow. Basically, that is a tree. So that is what we are seeing. So in the ring, computers are connected in a circular motion, one computer to the other. So one computer is connected to two computers. One computer is connected to the other two. That's the way it is in the ring. Now we see in the mesh there is a central device. A central device where all computers are connected to. Now in this central device, then there is one device is connected to the other. So in other words, we can say one device is connected to more than one device. Now because of this, we say it is the most stable, because when you cut one cable, look at the first one, the ring. When you cut one cable, it means the one computer is cut off from the other computers that are connected. And we can only see the disadvantage here. One computer cannot connect to two computers, so it cannot get information from two computers, the one on either the right and the left side. When you talk of a mesh, a computer is connected to all other computers to a line. So if one cable cuts, it will just cut the connection to one computer, but the rest of the computers will still be connected. That is a mesh. Now we talk of the star topology. The star is whereby there's one central device, then all computers are connected to that central device. It's a more stable, sometimes doesn't have more complication, doesn't have much cable usage. It's simple as such. So that one is a star. And unfortunately, once the computer is cut, it's the only one that is disconnected. The others remain. In the other system you saw, especially the first one, when the computer is cut, it is prevented or it disconnects itself from the sender device. So this is the different type of topology. And now we have a tree. The bus. Sorry, we never mentioned the bus. The bus is where now its devices are connected. There's one line of a cable that is information is being connected to. So information devices are connecting from this line that is there. So that is a bus. So in one length, then information, then the computers are connected. So we can see that a cut on that, either a cut on the cable from the computer, it will just be that computer to be separated. A cut on that line, it will be other computers on either sides that will stop communicating, because having a single cable connecting one computer to the other. So those are different topologies. And then we talk of the tree or hybrid. That's a combination of everything. So they are there. You know that only way it would be safe is where one or two computers are connected to more devices. So basically, that is just a connection that has been done. Now, how do computers or individuals, my phone is connected to the internet, my PC is connected to the internet, how do I get to be known? E.g., I'm on my phone, I'm searching on Google. Google, what's the meaning of translocation? I want to know the meaning of that. How is Google going to know and specifically bring that information to me? I have a laptop. It won't send to the laptop. It won't send to another person's device. It won't send to any other person. How is it going to know that specifically I'm the one who requested for that information and bring it back to me? So now this is what we meant in terms of the addresses. So each node, a node we mentioned is any device connected on a computer, be it a laptop, phone, whatever device that you're using. Nowadays people are using fridges that are connected to the network, TVs, different devices basically. So any node or device connected to the internet should be uniquely identified so that a network device can identify the sender and the receiver. E.g., we mentioned of a switch. A switch needs to get information from the sender, send it to from the receiver, the sender to the receiver. Now, how is it going to know that specifically the information to be sent is going to this person? So we need to identify all the devices that are connected. Now, so this information, once it is known, it then going to enable data to flow. So now these are the ones we're going to look at. Now there are two types of such information or addresses which the computer uses to recognize. Is what we call a MAC address and IP address. So MAC address and IP addresses. Now I want to get to know what is a MAC address, what is an IP address, and how do this help in the computer networking. So MAC stands for Media Access Control. It's also known as the physical or hardware advice. Now, a MAC address is a unique value associated with a network adapter called a NIC. Remember, we're talking of the Ethernet for hardware connection, for the wired connection of a computer. So wired connection, we talked of RJ47, RJ45. So RJ45 go on the Ethernet jack to connect the cable that enables computer connection to the internet through the wire. So now we talked of a NIC, network interface card. So that NIC, network interface card, they are saying each one has a number that has been, or a serial that has been engraved on it. On your network adapter, there is a number or a serial number that has been engraved on it. You remember those network adapters that we looked at in the second lecture when we're talking of computer parts? That one has a code. There is a number that is there. So that is what the computer uses to identify. All these phones, they have what we call a card or the same kind of a NIC type on the adapter, the network adapter. All devices that are able to connect, they'll have this serial number. So now serial number will be used to identify those devices that are on the network. Now, this MAC address is engraved on the NIC, that's a network interface card, at the time of manufacturing. This is permanent, you can't change it, no matter the situation. So the NIC is attached and can be physically identified on the network using the MAC, using its MAC address. So those are able to be identified because there's a special key that has been put. Now, what is an IP? This is called the Internet Protocol IP, Internet Protocol address. It's also a specific unique address that is used to identify a node or a computer that is connected on the network. Now, IP addresses, they actively help to find the MAC addresses. Now, what does that mean? If we know a computer's IP address, we can communicate with that computer from anywhere in the world. Now, unlike the MAC addresses, IP addresses can change if a node is moved from one network to another. E.g., you did me a hotspot. I'm connected to your hotspot. I have gotten an IP address. So the computer or your device knows that this computer is connected because of the IP address. You disconnect me, you connect me to another, I connect to another person's. I've gotten a new IP address. I'm identified by another. Now, if you people remember at some point, you used to use what you call VPN. So this VPN, all it was doing to make you use WhatsApp when it was banned to use, or to have access to some sites when your company doesn't allow some softwares or some things to be used for their internet, the VPN basically is hiding your IP address. On one point it will send you to South Africa. Tomorrow, after 3 seconds, it will send you to Australia. 3 seconds to send you to Zambia. That's the way it does. So it keeps confusing why this is what the hackers use. They need to keep changing the address, because if your address is known, you can easily be isolated and be cancelled. The computer has an intellectual system that's able to monitor your location and be able to disconnect you. But once you have this, that is what is going to lock you up. Some VPNs are there for even networks, this phone system that you use. Like we said, a phone company, it's not making the signal. Signal is free of charge. The only reason you are paying for that charge to buy data for 5 kwacha, 3 kwacha, 5 kwacha, 6 kwacha, why you're buying that, it's just the key they are opening to you because they have let that data access to your home or to your specific location. Now, why they are able to cut is because this IP knows your location, so it is able to tell them this person at this point, the data he bought has expired and it has to be this. Now, by installing this special VPN, though it is illegal, it will cancel you from being identified that this is the person that bought. In other words, you'll be jumping from one system to another, and the system will never know where you are or what you're doing with that computer. Basically, that is it. We come to the World Wide Web, WW. Now, this is a very interesting feature, and I wish you to follow through. Now, this is we can use it as an ocean of information, WWW. Since it's the ocean of information, and it is formed or stored in trillions of interlinked web pages and web resources. And this can be shared through the internet. What used to happen in the past was, if you want to view information, let's say you're all connected to the net, but you want to view information for someone who is in the States or outside the continent that you are in, you needed to have the access password. So on that individual person, it will pop up, this person wants to get information from you. Then you are able to give you passwords, then you're able to enter. Then now you can be able to share information. Because we said network, even here where I'm seated, I can have 2 computers, 1 cable, and I'll have a network. 2 computers will be able to share. But having from a long distance, intercontinent, different continent, different country, to have that information be shared from one area from one place to another, I needed to have some certain level of more like encryption. There will be an encryption that will be there, so I need to be given the access so that I can be able to access that information. Now look at this interesting thing of a WWW that came about. Now we come to see that in the 1990, by this big guy, we'll mention his name, the Sir Tim Berners. Now this British computer scientist invented the revolution World Wide Web in 1990, and it did this through the 3 fundamental things that we're going to look at. Because of this, it is able now to be able to access information, minus knocking on someone's computer and door and asking, I want to check this information, I want this. Information is freely now going to be accessed. Mind you, a network are just different computers that are connected together. There is nothing special. What you go on YouTube and check, it is something that it's a connection to another computer that is stored somewhere. What you go and check on any Facebook page, wherever, it is the big computer that is there. They are just allowing you access to connect to it and be able to access the information that is stored in their computer. Basically, that's what you're doing. Now, we don't want a thing whereby when you go to there, they start giving you enter a password, do this. You are able to freely go. You go to Google, you go to what? Now, these are big computers that they have to start asking for that. Now, because of that, and now this thing starts asking, who is this? You have come to my computer. What are you doing? What do you want? No, I'm this. Then you start telling your address, where you're coming from, what you're doing. It wants to know you and it brings information specifically to you. So now what this www did was to come and remove this, isolate this kind of a the big issue, so to say, that was there, and break it down to something simple. So I'm going to look at these three factors that has been brought by the www. So there's HTML, is URI, and HTTP. HTML, URI, and HTTP. Those three. Those are the things that we're going to look at. Now, this is the HTML, the hypertext markup language. Basically, it's the language that we use to design web pages. And through the web page, contents can be read and understood from any computer. So, HTML, it's just the language. So now we have what we call web pages. So people now start creating websites. That's the website. So HTML is what we use when you're creating the HTML, the website. Through that, we are all able to make one language. Before, each one would write whatever information on their computer, and it would be difficult to be understood. This computer can't understand, so there will be breakage of information. But because of HTML, one language, one system to create websites, all computer websites are going to be generated by this. And because of that system, everything can be understood. Wherever you are, whatever you asked for, search for a university of whatever nature, you're going to see the information and you're going to have everything that is written on that university, provided they have let it for free to be checked. Otherwise, you have to see that. You don't need to start now checking for translating that information, doing what is going to be put for free. This is what was brought in the World Wide Web through Mr. Lee. There is another one which you have, the URI, the Uniform Resource Identifier. Now this, you have used it a number of times. It's what you are calling a link. Send me a link, send me a link. It's a URI. Basically, it's a unique address or path for each resource located on the web. So what you're doing is, a web is more like a page. It's like a group of shops that have been brought. Instead of me coming to your shop, knocking, what do you have in your shop? I've got this and this and this. Then I check it. Okay, can I fit in, see my size and do this? I'll waste too much time coming to you. What we are doing is, we tell you, all of you make different shops, then present them on this platform. So you have a number of shops and you bring it on an online platform. That is what we're calling a website. So you bring a lot of pages of websites, thousands of them, such that when I search something online, I want a dress, I want a specific type, I want a shoe, I want a specific type, it's going to present to me everything from different shops that matches my search. Once it finds what I want, then I can go specifically to that shop. Now, if I found that information because I searched and the one who sent me maybe had no access to the internet, now how do I tell specifically this is what I found? Because the moment I close my computer, I will lose access to that file that I found. So I'm going to have this uniform resource identifier. Now, this is a specific address that locates that specific page where I found that information, that specific shop where I found that information that I want. So that is the URI code, the Uniform Resource Identifier. So that one will specifically give me the information that I want from there. Examples are some that have been identified in here. We call them the web addresses. Now, it's not now you see that in the URL code, there's what we call a domain. So the domain basically is there's a website. Then further on, it will contain the specific one. So, e.g., this is a shop that is selling What do I mean by not just a domain? It will not just have the shop name, the URI code. It will not have a shop name. It will also identify the shoe type, the shoe color, the shoe size, exactly the specific one independent individual thing that I wanted. It will not just show me a stack of shoes that I can start now choosing further on. This one is specific. It will take me to the specific location. So it will have different segments. What you can see highlighted in blue, it will have a website, the type of a website that sent that, or the specific shop name that sent that information from the thousands of shops that are there. Then from that shop, it will give me specifically the color of shoe, the size, exactly what I searched for. Now let's go to the HTTP. So the Hypertext Transfer Protocol. This is also a set of rules which is used to retrieve linked web pages across the web. And it's a more secure version, the HTTP. Now, we want to talk of the domain name or this website. We see that the internet is a vast ocean, like we mentioned. There is a lot of information available in the form of thousands and billions and trillions of information. Now, each website is stored on a server which is connected to the internet. So like we said, that website is basically a computer that is presenting information, because we said that to have a network, there have to be different computers that are connected. So for us to see information on the invest of what data that is in there, it's just a computer that they have that we can connect to. Now, each website, like we said, is stored on a server which is connected to the internet, which means each server has an IP address. We said that for any information to move from one space to another, we need an IP address. And an IP address, it is more advanced than the MAC address that each NIC cable has. Why? Because the IP address can change according to where you're connected to. So, e.g., I want to send something, then you you basically are connected in a certain institution. So the network will be, I can only send you something specifically to one location. That's what the MAC address will do. But with the IP, I can change. I can put something and I can connect to different people anytime I want by just logging through, matching the IP addresses, and we'll have the same information being free to flow. Now, so each device connected to the internet has an IP address that we know, and that's what we said. Now, to access a website, we need to enter its IP address. So we need to enter the IP address. A website, consider it as a shop or a computer or a device by someone. So now to access this, we need an IP address. Now, we can only enter by knowing the specific address. Now, as we all know, it is difficult to remember these IP addresses of different websites. Whatever website we want, imagine you want to search for schools, you have to enter websites, IP addresses. IP addresses are in form of numbers, 192.162.16. It's a lot of figures, like in a bunch of different types. There are IP4s, IP6. So in the 4 sets of numbers, each number can go up to 255 maximum. So this number starts from 0 to 255 in 4 branches. So number 0000255. Now, there are a lot of numbers, a lot of that. To know that, I'll bring you to the concept that has been brought in this paragraph. It's the same as for you to talk to one person or the other person, be it MTN or Airtel, you need to know their number, isn't it? That is true. You need to know the specific number for the person that you want to call. But to remember a phone number, it's very difficult. I don't know, maybe for some of you guys, it's easier for you to know a phone number of another person. You save 100, 1,000 of your numbers, you have them in your head, so that whenever you want, you're able to type them and press them and go like that. What you do is you attach what we call a domain name. You attach a name. It's just a name that you attach for the website, for that number, specific number. So you put Stephen, Jackson, Eric, Fashion, Daka, Vanda, Enoch, anything that you attach to that. So those names, that's what we are calling the domain name, because we can't remember the IP address, but we can remember something that we attach as a name. Some of the people, we save them as in the creditors for credit. Some of them, we save them according to the meeting that we had. Some of us, if we saw the names how we are saved in other people, you might find there are different names according to the memory that the person can have about you. If it was the shoe, you find the shoe friend. If it was in campus, you met student, fellow student, course mate. there are different names that are given so that people can understand each other according to the institution that they are in or the question that they are in. So as such, we mask these IP addresses using the domain names. So it is now easy then to remember the IP address. If I want to set something for the University of Zambia, I just have to type University of Zambia and it will take me to that. Instead of me going to type the number, because it has it's a computer that is there. So I need to know the specific IP address. Now to type 192.what, it's really cumbersome for me to get to know that. So I'll just type the name and it will give me, and simple, eBay, Amazon, I'll just jump and it will give me like that. So that is what this has reduced using the domain name. Now we have the DNS server. So now we said that instead of remembering this IP address, we assign a domain name to each. That is what we said. But to access a website, a browser needs to find out the IP address corresponding to the domain name entered. It has to find the name. E.g., I'm calling someone and the person I've saved the name is Nicholas Banda, Cosmet. If I call that name, it's only me who knows that Nicholas Banda. But if I call that person, for the call, it will not go direct to that person. It first bounces, if it is Airtel I'm using, bounces to the Airtel, then it starts going to that person. Now, as it goes, the Airtel, they need to know what phone number is mine and what phone number is Nicholas's phone number without any other details given to them. They'll just need to know automatically. So this is a DNS server. It's a server that is able to keep now these domain names and IP addresses together so that it can do a cross check. Oh, so this one has sent this to this one. What do you mean? Who is he looking for? He's looking for this one and specifically got to write that information to there. I type, I want information from CPU, Copperbelt University. I just type Copperbelt University website. Now, when I send that information, the computer doesn't understand what that information is. So from the domain name that I sent, which is the easier cover-up name, the IP address will be isolated. What is going to isolate that IP address is the DNS server. So the DNS server now will go, that is the domain, the domain name server is what now will go and bring back this name. So it will bring out the name, the number, and be able to link me. Because as we said, in computers that are connected together, it can only use the MAC or the IP addresses to send information specifically to this intended purpose and not other way around, because it will be cumbersome to start feeding it with other things that are there, the other information. This is a complex system to get to work around computers, and everything has to be fed. You have to type, you have to do what? Just this video to be presented here. There's a lot of things that have been done. There's typing that is needed. There's a lot of editing, a lot of presentation, a lot of things that have to be done. So just to make this information accessible for people to use it. Now, you find that a change that has to be made, new things have to start afresh. You have to start from the first slide, editing, doing a lot of things that are being done. So it's really cumbersome. And as such, they have made it open that you can do what you want. You can save this file here now, but to go inside and get to know, maybe it might be a bit tricky and it will cost you time. So now one thing that we have to know is people confuse the web with internet. Please don't confuse that. The web is not the internet. The internet, as we know, is the huge global network of interconnected computers. That is the network, internet. Internet is the huge interconnected computers, which may or may not have files in itself. But the web, on the other hand, is the interlink of connection of web pages on the computers that are accessible. What do we mean? To be connected to another computer, 3, 4 computers we connect, that is internet. So we just connect one computer to another, to another, to another, and make a global maybe we make a big one, intercontinental, intercontinents, we connect computers. That is just basic connection. But the moment we attach now the websites, now each one has a website of information. So we connect these websites to each other. That is what we call the web. So it's a collection of web pages. Now this www today gives us, the users, access to vast collection of information created and shared by people across the world. It is today the most popular information retrieval system. You would understand a long time ago. Imagine a time when the first computer was just made. Then the first information that was there is what the 2 people typed on different computers. Wow. Now the internet has gone broad enough and it looks smarter because each person is typing. I'm typing something. We're making this presentation here. Someone is making something. Someone is making. Tomorrow you make a search and you find this information popping up. So because there's someone who is doing something somewhere and this interlinked information comes and be popped up and saved on servers and anywhere, and we have this information. This is what the internet now we're doing, the networking of different systems. Let's go to the summary. Oh, double A summary. Wow. We're coming to the summary of this. So the first one, we said a computer network is an interconnection among two or more computers or computing devices. We never have a network of one computer. So there have to be more than two. Now, a computer network allows computers to share data and resources among each other. So whenever we talk of a network, there should be data shared. It should not just be a cable connection. There should be something that is moving. Data or resources has to be moving. Videos, songs, whatever. The moment there is that, there is a network. A network should be effective. It's not just having friends who are quiet. It will never be a friendship. You have a friend, that's my friend. You don't talk, you don't do anything. The moment you have an interchange of things, that is what is verifiable as this is a friend or these two people are connected, they relate. That is what it will mean. Networking devices are used to connect multiple computers in different settings. So networking devices are the ones that allow extra computer connections. We have a switch that will have 10 ports, 15 adapters. It's like an extension. So it will allow multiple computers to be connected. In a communication network, each device that is part of a network that can receive, create, store, and send data to different networks is called a node. Any device on the network is called a node. Any friends in this network that you have of friendship is called a node. So they are the ones that be able to share and send information. Based on the geographical area covered, data transferred, computer networks are categorized into the LAN. The LAN is the local area, one office. The MAN, the LAN, yes, one office. The MAN, different companies. The worldwide. Personal, one individual. And then we said this can connect a variety of nodes placed in a limited distance. One company specific information, that's a LAN. Ethernet is a set of rules that decides how computers and other devices connect with each other through cables in a LAN. So we have an Ethernet jack and Ethernet cables. They are the ones that we use to connect wireless cable in a wired way. Metropolitan, the MAN, is an extension of a form of LAN, but for different companies. Now, cable TV networks or cable-based broadband internet services, examples of MAN. There are different systems that they're able to link. Wide area network connects computers and other LANs and MANs which are spread. So there is a LAN which is the smallest, the MAN, then there's wide area network which is interworld, international kind of. The internet is the largest one that connects billions of computer smartphones and millions all over the world. A modem stands for modulator demodulator. So it modulates and demodulates. So that's a modem. So it demodulates and modulates. So basically this is what is going to convert electric signal to digital bits that you're going to use in your at home in your phone with a SIM card. Ethernet card, also known as network interface card, the NIC, is a network adapter used to set up a wired network. Now each NIC has a MAC address which helps to identify uniquely the computer network. Now we said a repeater is an analog device that generates a signal on the cable it is connected. Basically, a repeater is a booster of signal. A switch is a network device used to connect multiple computers connecting devices. On top of that, a switch can specifically send information to one specific device connected on one network. It can specifically send to one. A router is a network device that can receive data, analyze it, and transmit it to other networks, and it can allow or enable Wi-Fi to be added. A gateway serves as the entry and the exit point of network. All data that is coming in and going out of a network must pass through the gateway in order to be scrutinized. The arrangement of computers and other peripherals in the network is called the topology. So how computers are arranged is called the topology. And we have this, there's a mesh, we say the most confusing one, more like a bit of a complex. Each device connected to each other. 10, 15 devices, each cable connected to each computer separately, yet each computer connected to each separate. The ring, one computer to the other, so it has two computers on one side. The bus is a straight line, then all computers are connected to that straight line that is there. The star, all computers to the central device that is sending data. The tree, a mixture of different types of network connection. So we have mentioned and we have talked about that. Now the MAC address is also known as the physical address. The physical address or the hardware address is a unique permanent value associated with a network adapter called a NIC. So it's a unique permanent value associated with it. So we can't change it, and it's used to physically identify machines on a network. So machine, specific machine, computer to be identified, it has a MAC address. Now IP address, also known as the Internet Protocol, is a unique address that can be used to uniquely identify each node. Each device that is connected will have an IP. Unlike MAC address, IP can be changed and be removed from once a device is moved from one network to another, it will move with its own IP. The IP, different IP will be allocated. The internet is a global network of computing devices. So what makes the internet is thousands and thousands of computers that are brought together. The World Wide Web, or web in short, is an ocean of information stored in the form of trillions of interlinked web pages. And you are helped to be discovered this by Mr. Lee. HTML is a language which is used to design standard websites. So to design a website, we use standard website. These contents can be read and understood from any computer. In other words, it uses only one language. The URI, the Uniform Resource Identifier, URI, is a link, a web link that you send. It is a link that tells specifically the website and the specific information you want from it. It doesn't just give you the domain name. So the URI has a lot of things in it. There is a domain that is a specific website, and the specific information you want is attached. In the given example we gave, the URI is like there are different shops that have come online. They are all selling. Once you search for something, it will give you the name of a shop and the specific shoe type and the shoe color, shoe type, shoe size, everything specifically as per request. So that is what it will have. It will have a name of a shop and the type and the shoe and the specific thing that you want. So by copying that link and sharing it, you are allowing people to view specifically that specific information shared. Now the HTTP, the Hypertext Transfer Protocol, as we said, is a set of rules which is used to retrieve linked web pages. So, and it's the most secure type. Now, each computer server hosting a website or web is given a name against its IP. The name is a domain name. Conversion of a domain name of each web server to its corresponding IP address is called domain name resolution. So, it is done through the server called DNS server. So, DNS server, the numbers you have saved of the people in your phone, you have saved them, there is a name, there is a specific number. Why you have saved those names is for easy remembering. So what we are saying is the domain name is actually the name that you have assigned to that phone number, because the phone number specifically to remember it is difficult. But for the computers, once you enter the University of Zambia, it doesn't know what that University of Zambia is. It wants to know in terms of numbers that are given to it. So once you search that, the DNS server will change that name to the IP, specific IP address for that information that you want to access, and will give you the information. Because as human beings, you can't keep the specific numbers of the IP addresses. As such, you use the domain names. This is the end of the slide. Thank you very much for participating. I pray and hope each one has followed through the information that we have discussed. Thank you.